Okay, hi everyone. The topic of this video is to multiply and simplify trig functions, specifically using the Pythagorean identities, which we'll go over in just a moment. Before we do that, let's review what it means to be an identity in math in general. Identities in math are going to be equations that are true no matter which variables are replaced. So for example, if I had some number and I wanted to add 0 to it, well, I'm always left with the original number. This is an identity when adding 0. How about if I have a number and I multiply by 1? I'm always left with the number, right? Because that's an identity when multiplying by 1. Things that we can depend on to always be true, no matter what we're replacing the x with. Okay, now how about something a little bit more advanced, right? Let's talk about the difference of two squares. The difference of two squares, hopefully you remember in algebra, can be factored all the time into the root of both of them. So the root of x squared is x, the root of 25 is 5, and I add them together, I subtract them, and their product will be x squared minus 25 in this case, if you multiply that out. Those are equivalent expressions. It's an equation that's always true, no matter what I replace the x with, and no matter which perfect root that is. Okay. Now, for our Pythagorean identities, there's 3 things that I need you to remember before we keep going and go over them. The first thing I need you to remember is your basic trig identities, which hopefully you have learned already. This is a quick summary of them, their ratios and whether they're equal to. This one over here, I want you to remember is the same thing as y over x. That should be helpful later. Also, the other thing you have to remember is that any point on a unit circle will be, right, our x and y is going to be represented by the cosine of any real number and the sine of any real number, and those are our x and y's, right? Let's see, the third thing that you have to remember really is that trig functions at the end of the day are actually circular functions. And if you don't remember that, I will link a video that will shortly explain that for you. That way it doesn't take too much of your time. They are circular functions. And if we're talking about our unit circle, right, then we know that the radius of the unit circle is 1. And that for any circle, it would be true that x squared plus y squared is 1. This is the equation for a circle. We have a unit circle here, so our radius is 1. And we already said that the cosine of any real number is going to be our x, and that our y is our sine. And now this is where our Pythagorean identities are created, right? Basically just from this right here, this identity that we created because of the unit circle and the fact that these trig functions are circular functions. So here are our Pythagorean identities, and they really just come from substituting equivalent expressions, right? And then so for this one example, it doesn't have to be in this form. I can add or subtract to create equivalent equations. So for example, if I want to solve for the sine squared of x, if I subtract cosine squared x from both sides, then now I have 1 minus cosine squared of x on the right side. So these are equivalent equations, right? You can also do, what if I want to, instead, maybe I would like to solve for cosine squared of x, then this would be 1 minus sine squared of x, right? And I don't even have to write it like that. I could put the negative sine squared x first and then put plus 1, right? Because of commutative properties, right? Now, how about this one? This one might not have been as intuitive, But if you substitute again, going back to basic trig identities, then you can see where these come from. This one, if you'd like to, let's say, solve for the cotangent squared of x, then we would have the cosecant squared x minus 1. And then maybe, like, see how this one was solved for 1 on that side? We could do the same for this one here. We could just say that 1 is equal to the cosecant squared x, take away the cotangent squared x, right? So these are all the little things that you can do. You can do the same thing here, but I don't want to make the video too long. Just realize that you guys can substitute these things that are equivalent and move them around, right? Let's do a couple of quick examples and you'll see it in action. I also want you to get in the habit of checking while you're still learning. So we're going to look at Desmos graphing too. Okay, so if I have the cosine x times the tan squared of x plus 1, right? What do? Well, we know that the tangent is supposed to be cosine over sine, right? So the first step, you might want to be tempted to do that, but let's take a look up here. We see here that instead of substituting for the tangent as y over x, we can just substitute the entire parenthesis set. Even though the order is rearranged, it still means the same thing. So I can actually substitute the whole set for secant squared. Hopefully you can see that. So I have cosine of x actually times secant squared of x. If you look at your basic trig identities, you know that the secant is just the reciprocal of cosine. So temporarily, let's change it again. And we're still multiplying here. But now I'll have cosine squared of x in the denominator. And when I do this, you can see that we're going to get at least one of them cancel out, right? One cancels here, and the square is gone here. But then what's 1 over cosine x? We just said 1 over cosine of x is actually the secant. Okay, so that's that. Now, let's check. Check your work. Make sure that you graph the original and graph your result and make sure that the same thing. Right, so we'll come over here to Desmos graphing. And here was the result in blue. That's the graph. And then here was the original. And they're the exact same thing. Right, this is how you can verify that you actually simplified and ended up with something equivalent. Let's look at one more. And then hopefully that's good enough to get you going. Okay, example number 2, we have the cosecant x times the quantity of 1 minus cosine squared x, squared of x, right? So let's do it again, right? We know that the cosine has a reciprocal, right? But in the last one, we saw that we didn't have to mess around with substituting just one. We could take a look and see, you know, is there something a little better that I can substitute? So let's come over here and, oh, here we go. Over here, when we rewrote the very first Pythagorean identity, we came up with the sine squared of x is the same thing as 1 minus cosine squared of x, which, lucky us, is right here. So I can put here sine squared of x, and it's going to be multiplied by cosecant of x. However, right, our basic trig identities say that cosecant is the reciprocal of sine, right? So let's put 1 sine of x times sine squared of x, and it's happening again where this will cancel with one of these, and we're simply left with the sine of x, right? Let's graph the original. let's graph our result and let's see if we got the same thing. Okay, sine of x, hopefully you're familiar with that, very familiar I hope, by the time you got to these identities, is that we're looking at the graph of sine of x, and now here was the original, and they're exactly the same, which means we did it right, we simplified it right, and it might be a little frustrating that something that complicated just simplifies down to just the sine of x, but that's what the identities are doing, and testing is if you can see that, realize that, and algebraically get there. I hope the video was helpful, and good luck in your math studies.